Welcome to all of you in Sankalp Education Pratham classes. I am Sachin Patel, delivered lecture series on mathematical logic. Right now we are going with a statement pattern and the logical equivalence is here. Firstly, for this purpose, first of all, we have to go with the definition of statement pattern is here. Proper combination of statement letters and connectives. What is the statement letters are here? Statement letters is nothing but a P, Q, R and so on. What you can say, the statement which is taken inside the compound statement, and it is nothing but a statement letters are there, and connectives are there. Connectives are nothing but a and, or, negation, implication, double implications are there, and a proper combination of these is nothing but a statement pattern is here. And this statement pattern, for example, we have to consider P implies Q, negation of P and negation of Q, negation of P implies Q. Those are the nothing but the statement patterns, and those are the examples related to that statement patterns. Here P and Q are called as the prime components are there. Prime components P and Q are considered here. Now all possible combinations of that truth values of the prime components, what you can say, the prime components having different possible combination of that truth values of the related to that combination. At that time you will get the truth table of that one, and the truth table consists of how many rows and how many columns are done by using the consideration of this one. Let n be the number of statements are there, that means P, Q, R and so on. Let it consider then number of rows in the truth tables are nothing but 2 raised to n is here. That means n. Let us consider our statement pattern consists two statements, that means P and Q. At that time 2 raised to 2, that means 4 rows inside the truth table. If our statement pattern consists P, Q, R, 3 statements are there, at that time 2 raised to 3, that means n is equal to 3 is here, and therefore 2 raised to 3, that means 8 number of rows are there. And how to calculate the number of columns in our statement patterns? It is done by using the consideration of m be the number of connectives are there. Connectives is nothing but implication, and, or, negation, double implication is there. Just one thing is number of columns in a truth table is equal to m plus n is there. M plus n is there. M is nothing but a number of connectives, and n is nothing but a number of statements are there. M plus n number of columns inside the truth table. And here you have to consider connectives count once if it do same work at the previously counted with that connectives. What does it mean? For example, we have to consider here negation of P implies Q, and negation of P or Q is here. Here first of all we have to think about the statement P and Q are the prime components inside the statement, and you have to get into the consideration of these two are prime components. Then how many rows inside that statement pattern or truth table of that statement pattern is nothing but a number of rows. Number of rows is equal to 2 raised to n, and here n is nothing but a number of statement is nothing but a P and Q, that means n is equal to 2 is here, and therefore 2 raised to 2, that means 4 number of rows inside the truth table of that statement pattern is here. And right now number of connectives is nothing but a m is here, and number of connectives is count here negation, it is a 1 connective, 1, 2, 3, 4, 5, and it is a wrong one, because this negation is always calculated here, because it is counted here, because this negation do same work is here as well as here, and therefore this negation is counted only once is here, and this is your meaning of that sentence. That means connective count once if it do same work as that of previously counted with that connective. Previously counted, here negation is counted previously, and therefore it is not considered here, and therefore number of connectives are here 1, 2, 3, 4 are there, and m is equal to 4, and therefore number of columns is equal to m plus n. That means m is nothing but a 4 plus n is nothing but a 4. That means 8 columns are here. Right now we are going with the truth table of that statement pattern here, and by using the consideration of how to getting the different possibilities of truth values related to that prime components inside the consideration. First of all, we have to draw the truth table, and truth table of that statement pattern consists of 8 number of columns. First column is related to P, second column is related to Q. If it is, there will be a negation in the statement pattern, it is taken at the third column. Then ORing, ANDing, and so on, so related to that of the consideration. 1, 2, 3, 4, 5, 6 is here. Then you will get the 7, and last one is nothing but our statement pattern related to that one. First of all, we have to get the consideration related to this statement pattern. First of all, we have to get the consideration of P, then Q. That means 2 columns. First of all, we have to take the prime components, then whatever be the negation of that statement. Anyone having the negation in statement pattern? Yes, P having the negation, and therefore you have to take the negation of P is here. Then you will get the any combinations related to that one. Yes, this is the first combination is here, and therefore you have to taking the negation P implies Q is here. Negation P implies Q. Again another combination is here. This is the another combination is nothing but a negation P or Q is here. Negation P or Q is here. Sorry to say that here number of columns are nothing but 6. How it is calculated? M be the number of connectives and N be the number of prime component. That means 2 is here, and therefore 6 be the columns inside the inside our truth table, and those are nothing but first of all we have to get in the consideration of this one, and that means the first column is related first of all we have to take the prime components, then we have to taking the negation of any prime components, then combination of these components, and you will get the last one is nothing but your sixth component is nothing but a P. Negation of P implies Q. Negation of P implies Q, and this is not here considered. It is only one column is considered as a negation of P or Q is here, and therefore you will get the consideration of this truth table. First of all, how to get the number of rows inside the truth table. First of all, we have to get the consideration of P. If you want to take the 4 rows at that time, you can start with the half of that one, and you will take the, if you want to take the 4 rows at that time, first of all we have to take the 2 times T and 2 times false. 2 times false is here. After that, the second statement having the 4 rows, but here you can take the alternate 1 time T, 1 time false, 1 time T, 1 time false, and those are the nothing but all combinations of that prime components related to truth values of that one. And right now here we are taking the negation of the truth value, negation of truth value of P. P having the truth values are T, T, F, F. Right now we have to taking the negation of P. That means you know that the rule of negation is nothing but if your statement is true, then you will get the false inside this one, and therefore is nothing but F, false is here, therefore true is here, false is here, therefore true is here. Right now we are going with the implication is there, and implication consists of first statement and second statement. First statement is nothing but this is your first statement is here, that means this is S1, and this is your second statement is here, that means S2. That means S1 is this column and S2 is this column is here, and S1 and S2. That means we know that first statement is a true and the second statement is a false, at that time implication is a false. This is a rule of implication. By using that rule, you can going with the consideration of the implication of these two. That means first of all we have to going with the negation P. This is the first column, first statement, and Q is second statement is here. Q is the second statement is here. That means you can going with the false true. That means you will get the true is here, because our rule says that first statement is a true and second statement is a false. At that time it is a false. First statement is a false, second statement is a true, it is a true. First statement is a false, second statement is a false, it is a true. First statement is a true, second statement is a true, it is a true. And first statement is a true, second statement is a false. That means first statement negation of P is a true, and second statement Q, that means the second statement Q is a false. At that time it becomes a false is here. Similarly, you can find out the negation of P or Q. Or what is the rule for the or? The rule for the or is nothing but if both statement are false, at that time it is a false. Both statement are false, at that time it is a false. By using the rule of or is here, if both statement are false, then it is a false. You can going with the negation of P, this column, and Q, this column, and you want to take the or is here. First of all, what is the false? True. That means it is a true. False, false, at that time it is a false. That means both statement are false, at that time or is a false, and therefore negation of P or Q is a false here. It is a true here, it is a true here. Then you want to taking the consideration of AND operation related to these two. These two having the AND operation is here, and therefore it is a sixth column in our statement pattern, and it is nothing but a consideration of these two is nothing but a and is having the rule is if both statement are true, then it is a true, otherwise false. If both statement are true, then it is a true, otherwise false. Here this statement is a true, this statement is a true. That means this first statement, this second statement, this statement true, this statement true, this statement true, then it is a true is here. This statement true, this statement false, then it is a false. This statement true, this statement true, then it is a true. This statement false, this statement false, that means it is a false. That means you will get the truth value for that statement pattern is nothing but this one, and it is taken inside the bracket. True false is here, and this is a truth table related to our one statement pattern is here. Right now we are going with another statement pattern is here. P and Q implies negation P or Q, P or R. That means it contained three prime components. That means inside this you will get the P, Q, R prime components. Prime components. That means number of statements is nothing but n is equal to 3 is here, and therefore number of rows in a truth table is equal to 2 raised to n. That means 2 raised to 3. That means 8 number of rows are here. And number of connectives is equal to m is equal to, right now we can count the number of connectives. This is 1, 2, 3, 4 connectives are here, and therefore m is equal to 4 is here, and therefore number of columns in a truth table is equal to m plus n. That means 4 plus 3, it is equal to 7. Right now it is considered m is a number of connectives, that means 4. No any repeating connectives here considered, that means this is and statement and connective, it is implication, it is negation, it is R1, and therefore you will get the number of connectives are here 4 and the number of statement are 3. Number of statement are 3, therefore number of rows in the truth table is 2 raised to n, 2 raised to 3, that means it is equal to 8, and number of columns in the truth table is equal to m plus n, 4 plus 3 is here. Right now we have to draw the truth table related to that one. First of all, you have to get the consideration of this one here. First of all, we have to draw the truth table related to that one, and inside this you have to getting the first 3 columns related to prime 1. These 3 columns are nothing but related to prime 1. That means you will get the P, Q and R, the prime 1. P, Q, R. If any one statement having the negation, then it is taken as a 4th column is here. That means a negation of P is here. Negation of P inside the our statement pattern, and therefore negation of P is here. Then any combinations related to that one, you will take the consideration of P and Q is here. P and Q. Then you will take the consideration of negation of P or R is here. Negation of P or R is here, and our last column related to that combination of these 2 columns is nothing but P and Q implies negation P or R is here. Negation of P or R is here, and those are the 7th columns related to that truth table. Right now we are going with 8 rows related to that one as follow. Here first statement is P, and you want to take the 8 columns are here, 8 rows are here, and for this purpose first of all we have to take if it is 8 rows at that time, first prime component having a 4 true and 4 false is there, and therefore you have to take the true, 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 and then you can replace then remaining 4 are taken as a false, 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 and those are the 8 rows related to your first prime component. It is done by using 4 true and 4 false. Then a second prime component is taken as a true, 2 true, 2 false. That means you can make it half. That means you will take the consideration of true, true, then you will take the false, false, then you will take the true, true, and then again you will take the false, false. That means 2 true, 2 false, 2 true, 2 false. Then the third prime component is here, and it is taken as half of that one. That means 1 true, 1 false is here. That means 1 true, then false. Then here we take the false, here we take the false, and here we take the false. And in between these two, you will get the true, true, true. That means if you having the 3 prime components, at that time you will get the 8 rows are there. First prime component contain 4 true, 4 false. Second prime component contain 2 true, 2 false. Then third prime component contain first 1 true, 1 false is there. Similarly, you can get the 16 is there. At that time, first component contain 8 true, 8 false. Second component contain 4 true, 4 false. Third component contain 2 true, 2 false, and fourth component contain 1 true, 1 false is there. Right now here you want to take the consideration of the negation of this, negation of that P, and therefore it is a negation of P is nothing but it. Here is a true, then it is a false is here, then it is a false is here, it is a false is here, and it is a false is here, and then you will get the here false, then it is a true, 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 and true. That is a negation of that of prime statement, that means a P. Right now we are going with a P and Q is here. We know that the rule of AND is what? If both true, then it is a true, otherwise false. If both true, then it is a true, otherwise false. And it is related to P statement and Q statement. These two statements are considered here, P statement and Q statement. If both true, then it is a true, otherwise false. Both true, this true, then it is a true. This true, then it is a true. This true, this false, then it is a false is here. True, false, then false. False, true, false. False, true, false is here. False, false is here. False, false is here. That means both statements are true, then it is a true, otherwise false. Right now we have to taking the ORing between the negation of P and R is here. Negation of P column is here and R column is here. And these two columns are considered right now. These two columns are considered, and from this column you will get the consideration of R. What is the rule for R? If both false, then false, otherwise true. If both false, then false. Here negation of P is a false, it is a true, then it is a true. This false, then both false, then it is a false is here. Both false, then false, it is a false is here. This is false, it is a true, true is here. False, then false. True, it is a true. True, false, it is a true. True, it is a true. True, false, it is a true. Because here only one, both false, then it is a false, otherwise true is there. Right now we are going with the implication, and implication here, first of all, this is a statement 1. This is a statement 1 is here, and this is a statement 2 is here. It is the most important thing, because in implication your first statement and second statement is the most important, and first statement is your P and Q is here. That means this is the first statement and this is the second statement. First and second. If first is a true and second is a false, then it is a false, otherwise it is a true. And therefore you can going with the consideration of this one. True, then it is a true is here. True, false, that means first statement is a true, second statement is a false, then it is a false is here. First statement is a false, true, then it is a true. False, it is a true. False, true, 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 it is a true. Only here is a false because of first statement is a true and second statement is a false. At that time implication is a false, otherwise it is a become a true. And this is your truth value or all truth value combinations related to your statement pattern, and it is nothing but a truth table related to that statement pattern. Here you will get the 3 prime components, that means the 3 statement, and therefore number of rows inside this statement pattern is nothing but 8. How we can get the 8 truth table truth consideration or all possible components related to that one is taken 4 true, 4 false, 2 true, 2 false, and 1 true, 1 false, and so on. You will get the truth table related to that one. And right now is here P and Q and negation P and negation Q. Here you think about the and. That means there are 3 and operators of connectives which are not taken as ones, because here it is having 2 different P and Q. Here it having 2 different P and Q. That means negation P, negation Q is here, and here it having the 2 different statements are there, and therefore these 3 ands are differently work, and therefore it is not count once, and therefore it is taken as separately. This negation and this negation also taken separately. And right now number of rows and number of columns related to that statement patterns, it is considered here. P and Q are 2 prime components, and therefore it having the 2 statements, and therefore a total number of rows is 2 raised to n, that means 2 raised to 2. That means it is a 4, and it is taken here. And here connectives are nothing but 1, 2, 3, 4, 5, and therefore 5 plus 2 is equal to 7. 1, 2, 3, 4, 5, 6, and 7 is here. And from this you can calculate the truth table related to that one. First of all, negation of P is here, and negation of P is taken as true, then it is a false, Here also it is a false, then it is a true, then it is a true is here. And negation of Q is taken as a true, then it is a false, false, then it is a true, true, then it is a false, false, then it is a true. According to rule of the negation, if a given statement is a true, then then the negation of that statement is a false, and given statement is a false, then negation of that statement is a true, and according to that one you will get the consideration of this one. And right now P and Q is here. P and Q is nothing but what is the rule of and? Rule of and is nothing but if both statement are true, then it is a true, otherwise false. And therefore you have to consider P and Q is here. P statement is here and Q statement is here. P and Q, both statement are true, then it is a true, true, false, then it is a false, false, true, it is a false, 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 it is a false is here. Right now similarly you want to calculate the you will get the consideration of negation of P and negation of Q, and is here, and negation of P and negation Q is here, and statement show considered what? If both are true, then it is a true, otherwise false. That means these false, then it is a false, false, true, both are true, then it is a true, otherwise false, and therefore false, 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 true, it is a false, true, false, then it is a false, both are true, then it is a true is here. And right now this is one statement and this is the second statement, and once again and operator is here. That means you want to take the ending or conjunction of these two statement, and the conjunction of these two statement is nothing but if both statement are true, then it is a true, otherwise false. Then first statement is a P and Q, and second statement is a negation P and negation Q. From this is true, this is false, then it is a false. This false, then it is a false. This false, then it is a false. This false, this true, it is a false also. And therefore all considered, all consideration related to that one is a false here. And it is also it is a one special case related to your truth table. If all possible truth values are false, then it is called as a falsy, and if all possible truth values are true, then it is called as a tautology, and it is a falsy, also called as a contradiction is here. And if true and false are taken inside the consideration, then it is called as a contingency. If all possible considerations are false, then it is a falsy or contradiction. If all truth values related to your statement pattern are true, then it is called as a tautology. And if true and false are combined inside the truth values of all possible consideration, then it is called as a contingency related to that one. Now, if you like that video, please subscribe my channel and press on bell icon to get next notification related to your mathematical logical series. Thank you.